All right, so let's take a quick look at a problem, and I want to get you a chance to work a little bit too, so I'll be very brief on this. Let's do try something like this. Let's take a look at the function. How about f of x equals? Let's do the greatest integer function of x minus 2 over x minus 2. Is that going to do what I want? I think it will. As x approaches 2. Okay? So what does that seem to give us for an answer if I evaluate directly?
0.
0 over 0, right? More work. So what's the more work look like here? Well, this is a little different situation because the greatest integer function of x minus 2 is not something that I could write it as a piecewise function, and we actually will look at that later on in the class. We'll look at a way we can write this as a piecewise function and do some analysis of the piecewise function. We'll get to that, but for now I'm not going to do that. What I want to do instead now is kind of fit this into the limits discussion we were having earlier. Let's just tackle this thing from both sides and see what kinds of results we get. We take this limit as we approach 2 from the left and as we approach 2 from the right, and see what that tells us. So how about if we start going from, let's go from the right. I'll go from the left. What's the limit of this function as x approaches 2 from the left? So give me an example of what number the 2 from the left would resemble. 1. Okay, maybe one that's a little closer to 2. 1.9999. As we get real close, it's just going to be 1.9 something, right? Okay, so then if I evaluate this one directly, what am I going to get?
Almost 0. So.
Okay, so I'm going to get something.
You get 0.
Now, what am I getting on the top? If I'm plugging in for x something like 1.99999 something, right? Then this is going to look like the greatest integer of what number in there? How would you describe that number? It's going to be, it's going to be 0 negative, isn't it? Yeah, it's going to be 0 negative. Okay, so if I take, if I'm taking the greatest integer of 0 negative, and let's just focus on the numerator just for a second here while we're at it. Then we'll deal with the denominator in a second. What's that going to be? Now, based on our discussion of the greatest integer function that we had yesterday, you can look at this any number of ways. What if you use the bead analysis?
Oh, it's going to be.
Yeah, if I've got knots at all the integers at -2, -1, 0, 1, 2, etc., and I start with a bead that's just a little bit to the left of 0, and I'm pushing it to the left, where's it going to stop? -1, isn't it? Right? So the top is -1. Now the bottom is. Okay, yeah, it really is approaching 0, isn't it? Right? I mean, we really are getting something like 0 minus on the bottom. So this is looking like -1 over 0 minus. Now that tells us something a little bit more. What is that telling us? Say it again. It's a big number, isn't it? Because I've got a vertical asymptote, right? I've got a 0 on the bottom, but not a 0 on the top. And that's one of those limits that originally, remember we said we had 3 varieties of answers. We had the number answer, done. We had a number divided by 0, and which we called no limit at the time. But now we're being a little more specific, and we'll get to that. And that's what this is. And then we had the 0 over 0, which is more work. Well, how do we analyze this? What is this really trying to be? When we say no limit, Tateo was right, it's big. That means infinite, right? The vertical asymptote always gets at some infinite behavior in the function, so we know we got an infinity there. The question is just, what kind of infinity is it? Is it positive or negative? We can tell. It's positive. How come? Peter, how come? Negative over negative, yeah. We've got a -1 divided by a very small negative number, right? And negative divided by negative is always a positive result. So we know that's a big deal. Now, instead of just throwing up our hands and saying no limit, we've said something really important there. We've said that as an ant walks towards 2 from the left, he is walking up an infinite vertical asymptote, right? And that's a big behavioral thing. Okay, makes sense?
Yeah.
Okay. Now what about from the right? Let's look at that one. So same issue. So what kind of numbers are we talking about here? 2 plus.
So I think,
2.00 something, right? 2 point something small. So then if I take this limit, what kind of a number are we getting inside the greatest integer brackets? Okay, a positive 0, right. And on the bottom, we're getting a positive 0, okay? Anybody care to hazard a guess as to what our ultimate answer is going to be here? Oh, it's going to be 0, isn't it? Yeah, so let's talk about why. What is this actual value up here? 0, because this means that the bead is slightly to the right of the knot at 0. So when we push it to the left, it's going to stop at 0, isn't it? So we're getting 0 over 0 plus. Now the question is that undefined? Is it more work or is it an answer? It's an answer. How come? Yeah, 0 positive is a number. So what if it's small? The top of the fraction is exactly 0, right? And exactly 0 divided by any number, whether it's a trillion or 10 or 0.000000001, doesn't matter. If it's a number that's finite, right? Then this answer is 0. Does that make sense? Okay. So that's the one I wanted to get to. That's kind of strange behavior, but so walking from the right, the ant is approaching a definite value, y equals 0. Okay, but he's got this asymptote walking from the left. So there's a lot going on there that we would not have discovered previously had we not approached this from different sides. Okay, why don't you guys go? We'll get some work in here.